Okay, good morning, friends. In chapter number 11, work and energy, last time we discussed about the scientific conception of the work. In this topic, we discussed the two conditions that we need to satisfy for the work to be done. So, first condition, that is a force should act on an object, and second one, the object must be displaced. So, we discuss activity 11.3 now. So, in this activity, that is a think of situation when the object is not displaced in spite of a force acting on it. Here we apply force to push a steam engine or any heavy vehicle like a tractor or the truck. Okay, so we get completely tired, but the engine or the car or the truck does not move. In this case, we have not done any work. Second one, think of situation when an object gets displaced in the absence of force acting on it. So for that, we take the situation upper on a horizontal air table, that is frictionless table. When an impulse is given to the pork, it moves, that is gets displaced with constant velocity in the absence of the force. So if we are in the moving train, we observe the trees, pillars, buildings, okay, etc. outside moving in opposite direction. Now work done by constant force. So let us consider that is a on the table, that is a one object should be kept on the table, and force F should be applied on one side. So due to the force, the object will be moved the distance s. So displacement should be s. So let a constant force F act on an object, and let the object be displaced through the distance s in the direction of the force as shown in the figure. Let W be the work done. Here we define work to be equal to the product of force and displacement. So work done is equal to the product of force and displacement. Okay, the symbol of work done is W, the symbol of force is capital F, and the symbol of displacement is Fs. Okay, so W is equal to Fs. Now here, that is F is equal to, we take 1 Newton. Okay, force, that is the SI unit of force is Newton, and SI unit of displacement is meter. Okay, so if we take in this equation F is equal to 1 Newton and S equal to 1 meter, then work done by the force will be 1 Newton meter. So here the unit of work is Newton meter, okay, or the joule. Now we are to take example 11.1. A force of 5 Newton is acting on an object. The object is displaced through the 2 meter in the direction of the force as shown in the figure. If the force acts on the object all through the displacement, then work done is 5 Newton multiplied by 2 meter. That is F is equal to, that is W is equal to force into displacement. Okay, W is equal to force multiplied by displacement. Force is equal to 5 Newton and displacement is 2 meter. So 5 to 10 Newton meter or 10 joule. That is in text question. Similarly, that is force of 7 Newton acts on an object. The displacement is say 8 meter in the direction of the force as shown in the figure. Let us take it that a force acts on the object through the displacement. What is the work done in this case? So previously we discussed that is W is equal to product of force multiplied by displacement. Here force is 7 Newton and displacement is 8 meter. So W is equal to force multiplied by displacement. So as shown in the figure, W is force equal to 7 Newton multiplied by 8 meter. 7 8 ja 56 Newton meter or 56 joule. Okay, Now we consider that is a one situation. Consider the situation in which the force and displacement are the same direction. Okay, here as shown in the figure, that is a one table, and on the table that is a one toy car. Okay, and beside there is a one girl, and toy car is that is tightly with, that is one, it to be connected with the string. Okay, and that is this string should be forced in one direction. Girls will be pushed. Okay, they can be pull the string in one direction. So obviously the force is force as well as direct, that is displacement in the one direction. Okay, so here a baby pulling a toy car parallel to the ground as shown in the figure. The baby has exerted a force in the direction of displacement of the car. So in this situation, the work done will be equal to the product of force and displacement. So here force and displacement is in same direction, so work should be taken as a positive. Okay, force is taken positive. Now consider that is situation in which the object moving with the uniform velocity along the particular direction. Now a retarding force is applied in the opposite direction, that is the angle between the two direction is 180 degree. Let the object stop after displacement. In such a situation, the work done by the force is taken as a negative. Okay, so it is clear from this discussion that the work done by the force can be either be positive or negative. Now in this activity, that is 11.4, that is lift an object in upward direction, and work is done by the force exerted by you on the object. The object moves in upward direction. The force you exerted is in the direction of displacement. However, there is the force of gravity acting on the object, and which one of these forces is doing positive work? Give the reason. Now here you lift the object in upward direction. Suppose that is on the ground, and there is a should be kept one cricket ball, and you lift this cricket ball, okay, in upward direction. Okay, so here the work done by the force applied by you is the positive, because in upward direction. Okay, force and the displacement, it should be in same direction, so it should be work should be positive, because it acts in direction of displacement on the object. Now in second situation, which one is doing negative work? Give the reason. The work done by the force of gravity is negative because the force of gravity acts in the downward direction, that is in the opposite direction of displacement of the object.